weakened splice, after more than 12,000 cycles, gave way. The pressure difference between the cabin and the outside air, contained until that moment, released instantly into the rear of the fuselage. The explosive decompression destroyed the rear of the aircraft. The vertical stabilizer, the large tail fin that keeps the aircraft pointed forward, was torn away. It fell into the sea below. With it went the hydraulic lines, all 4 of them. On a 747, the hydraulic systems power the flight control surfaces, the rudder, the elevators, the ailerons. Without hydraulics, the pilots had none of these. Captain Masami Takahashi and his crew were now operating a 747 with thrust from 4 engines and almost no way to direct it. What followed has been studied in aviation training programs ever since. For 32 minutes, the crew used differential engine thrust to attempt to steer the aircraft. They managed to keep it airborne. They fought a phenomenon called phugoid oscillation, a slow repeating pitch cycle that, without control surfaces, the crew could only partially dampen. The aircraft climbed and descended, turned without being commanded to turn, and drifted northwest over the mountains of central Japan. At 6:56 p.m., Flight 123 struck the ridge of Osutaka Mountain in Gunma Prefecture, breaking apart on impact. Of the 524 people on board, 520 died. 4 passengers survived, found in the wreckage the following morning. Japan's Aircraft Accident Investigation Authority, now known as the Japan Transport Safety Board, led the investigation with NTSB participation. Within months, investigators had traced the structural failure back to the repaired bulkhead, and from there back to the 1978 Boeing repair. The metallurgical evidence from the recovered wreckage confirmed fatigue cracking originating at the splice joint. The crack pattern was consistent with the reduced fatigue life of a